Okay, we're going to finish up this section with this last page here. So in Math 65, they're actually going to want you to do this on the very, very first day. You're going to want to graph two lines on the same axes and then find out where they intersect. We call this actually a system of equations, and where they intersect is the solution to both lines, right? So if I want to graph this, the best thing I can do, because I have a fraction, is if I draw a table of values, x and y, remember that the easiest number to find is when x is 0. When x is 0, what's y? Right? Now, if I don't want to have fractions, I really don't want to graph fractions. So if I plug in 1 here, I'm going to get a fraction. What would be the number that I could plug in for x that would get rid of the fraction, that would clear the fraction? Yes, -3 and +3. Okay, if I plug in -3, I'm just going to do it right here. Y equals -2/3 times -3 over, how do I make that into a fraction? 1 plus 6. Okay, you see what ends up happening here is that my 3's cancel. I get -2 times -1. This becomes a -1 because of the negative. -2 times -1 is 2 plus 6 is 8. Okay, I'm going to do the same thing with +3. Watch this. Y equals -2/3 times 3 over 1 plus 6. My 3's cross cancel. 3 goes into 3 one time. I get -2 plus 6 is 4. That makes it much easier to graph. If you want to try and graph a fraction, good luck to you. It's just not easy to do. So that's why the idea of using multiples of the denominator gives us the concept of clearing the fraction. Any questions on that? That's a pretty sophisticated concept. So if I plot these points, I have -3, 8. So I go over 3, up 8, over to -3, up to 8, -3, 8, 0, 6, 0, 6 is here, and 3, 4. 3, 4 is here. 3, 4. Okay, so now I take my handy ruler and I'm going to connect the dots. So, make sure you do it accurately. Okay, and here's my line. Draw bold lines all the way. I don't like to see, like, people sometimes will draw just a little tiny line. Just draw it all the way through the graph. Okay, let's do the next one. Y equals 2x minus 2. Now, the easiest one to find, what's your favorite point to find? 0. X is 0. What's y? -2. Good. Maybe I do -1 and 1. If I plug in -1, don't I get -2 minus 2, which is -4? I shouldn't be doing this in my head. If I plug in 1, what will I get? 2 times 1 is 2, minus 2 is 0. You can write that out too. I kind of shouldn't have done it in my head, but anyway. -1, -4 is down here. Here's -1, -4. 0, -2 is here. And 1, 0 is here. So I can draw my dot, 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 my lines. And check it out. They meet up. The ordered pair where they cross is going to be 3, 4. If I plug in 3, y equals 2 times 3 minus 2. Y equals 6 minus 2, which is equal to 4. I just plugged in 3 for x, and I get 4. So that proves that that point is on both lines, right? I found that point on my first table, and then I just plugged in x equals 3, and it gave me 4. that's a point on the other line too. So that's their shared point. And by the way, that is the very first section of Math 65. When you go into Math 65, they're going to want to know on the first day, can you graph a line? Perfect. Can you graph two lines? Perfect. Can you find out where they cross? We just did that. So you have the first lesson of Math 65 learned. Okay, let's look at this word problem now. So example 6 says, a moving truck company rents trucks for a flat fee of $50 and 50 cents per mile. Let X represent the number of miles, so we define the variable. X represents the number of miles driven, and F of X, which is the same thing as Y, represents the cost of renting the truck. State the equation representing the total cost, F of X, for renting the truck for X number of miles. Can anyone tell me what they think the function would be, the equation? We'll start with F of X equals, yes, 0.5. You could put 0.5 or 0.50x, same thing, right? Maybe people want to recognize it. A lot of times that's one of the biggest misconceptions. Sometimes people will see 0.5 and they'll think it's 5 cents instead of 50 cents. So sometimes it can be helpful to put that 0 there. Now, what does this mean to evaluate F of 500? What is that asking us for? Yeah, plug the 500 in for the X. So F of 500 means how much money will it cost if we rent the truck and drive it for 500 miles. And a lot of times you'll see evaluate and interpret, right? So we'll have $50 as our flat fee plus, I don't know what 50 cents a mile is. Actually, I do. Wouldn't it be $250? Okay. I'll just trust you. $250. You did the math, right? No? And then 50 plus 250 is 300. So if we were to being asked to interpret, something like that, what it means, the cost to drive 500 miles is $300. All right, moving company. All right, graph the equation in part A on the axis below. Be sure to mark a scale and label the axes. Plot and label the information from the graph. Plot and label this point. Okay, and we're going to do this here. So what should our x-axis be? If we were going to label that axis, what would you want to label it with? What are the x representing? The x is representing the number of miles. And the y-axis, or f of x, represents the what? The cost. Okay, now, the whole idea of scale is like, well, what do you want to count by? Would it make sense to count by 1 mile, 2 miles, 3 miles, 4 miles? What kind of makes more sense to you? Yeah, maybe 100 miles, 200 miles, 300 miles, 400, 500, 600, 700, 800, 900. I can count it like this as long as I'm still being consistent. The only reason why I put that in, now you could have also, here's another fancy thing you could have done. You could have said 1, and then these miles are in hundreds. You see that? 2, 3, 4, 5. If you wanted to do it that way. You see? Now, what about the cost? What does it make sense to count by for the cost? Hundreds as well? You want to count by hundreds? I might even suggest counting by 50, only because if I count by 50, 50, 100, 200, 300, then I'm able to actually draw that y-intercept. Because remember, if you drive 0 miles, you still have to pay $50. After 100 miles, you would pay $50 more. So 100 miles would cost you $100. So wouldn't you be paying an extra $50 for every 100 miles? Because if I go 100 times 50 cents, I get $50 more. So now every 100 miles, I pay $50 more. And would it make sense to connect these points? Could you drive between 100 and 0 miles? Yeah, you could drive 99 miles. So there's my line going on for infinity. So we have a scale. We've labeled the axes. Labeling the axes includes what does the axis represent, right? Plot and label the information from part B. So right here, this was 500 miles, cost $300. So 500 miles, $300. Or you could have used numbers and then said those were in hundreds. Plot and label 200, 150. 200 miles is here, and 150 is here. So here's the point, 200, 150. Using a complete sentence, what does this point represent? So what does the x represent? What does the y represent? Can anyone tell me? If you drive 200 miles, the cost is that was supposed to be a dollar sign, 150. Yeah. Okay. Very good. That's the same thing we did for this one here. Any more questions? What's the domain of this situation? Just because we were talking about domain and range. Who can tell me what the domain in the context of the word problem would be? Notice that we only use the first quadrant. Why do you think we only use the first quadrant to graph this? Why didn't I have quadrant 2, 3, and 4? Because you can't have negative miles, right? And you would never have negative money. So the domain could be from 0 to infinity. What about the range for the word problem? What's the smallest value you'll pay if you rent the truck? For 0, it would be $50 to infinity, right? Of course, it wouldn't really make sense for it to go to infinity because you really can't drive an actual infinite number of miles, but you get the idea. Okay, any last questions before I push stop?